In mathematics, every day we deal with numbers, and these numbers they can come in large numbers. Okay, so to help to understand them and help to work with them, we come to a topic which is called matrices. Okay, so this is going to be our introduction to matrices, where we are going to learn how are we going to deal with the large numbers. Okay, so the data is being arranged in matrices. Welcome. First, let's understand what we are going to talk about today. Okay, so the first thing we have to understand is the definition. Okay, so the definition we are going to talk about is the definition of a matrix. Okay, so a matrix is an arrangement of numbers in rows and columns. Okay, so we can write the definition as an arrangement of numbers in rows and columns. Okay, so this arrangement is what we call matrix, and you are going to be arranging numbers in rows and columns, and you are going to be dealing with numbers in rows and columns. Okay, so now let's talk about the notation of a matrix. Okay, so the first thing you have to remember that is a matrix is represented by a capital letter. Okay, so let's say I want to represent a matrix as matrix A. You can represent it as a matrix X, matrix Z, matrix P, and so on and so on. Okay, so let's say the matrix A. Okay, so it is represented using the square brackets. Okay, you can use it. You can use square brackets, or you can use these curly brackets. Okay, so and these numbers they are represented in rows and columns. Okay, so let's say we have an example matrix A in square brackets is A, B, C, D, E, F, G, H, I. Okay, so this is our matrix. Okay, in this case, you can see that these are what we call rows. Okay, so in this case, you can see that here we have 1, 2, 3 rows, and these are what we call columns. Okay, and you can see in this case we have 1, 2, 3 columns as well. Okay, so this is what we call a matrix notation, and each element of this, like A, B, and C, and so on until to I, we call them elements of this matrix. Okay, or entry. Okay, so this is it on the definition and notation. Remember, you represent it with a capital letter and in a square brackets or in a curly brackets like this, and you put your entries in this. Okay, so it can be 2 by 2 like this. It can be A, B, C, D, any order. Okay, so we're going to talk about the different orders of matrix in the next chapter, but this is the definition and the notation of a matrix. Okay, now let's understand the size of a matrix. Okay, so in naming matrices, we have to understand how long is it, how big is it. Okay, so we use the size. Okay, so the size of a matrix is written in these ways. You write the rows first, then you say by, and you write the columns here. Okay, so this means that if you want to write a size of a matrix, you just have to write the number of rows and the number of columns. We have successfully written the number of rows. Okay, so this is it. Let's say we have a matrix here. It has these numbers 3, 1, 2, 1, and 6, 2. Okay, so this is a matrix. I just took the random number and it is a matrix B. Okay, so in this case, if you want to write the size of this matrix, okay, so if you want to write the size, okay, so what you do is you first count the number of rows. First, make sure first the number of rows 1, 2, 3. Okay, in this case we have 3. Okay, then you put by. Okay, then here we have 1, 2. Okay, so this means that this matrix is a 3 by 2 matrix. Okay, so this is very important in our operations. We will see that later when you start to add or subtract or multiply these matrices. It's very important. Make sure you understand that. Okay, so this is it on size of a matrix. Make sure you remember that you have to name the rows first, then the columns second. Okay, next we are looking at locating values in a matrix. Okay, so this is just basic helping you understand what is a matrix. Okay, so I'm going to be telling you how to locate values. Okay, so given a matrix A, okay, and it is given with numbers. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is our matrix. Okay, so you can name the size. In this case, you know that there are 3 rows. Okay, so you can say that this matrix is 3, and you can know that there are 4 columns, so it's 3 by 4 matrix. Okay, so given this matrix, to locate a number inside, let's say we want to locate this 7. Okay, so what we do, the first thing is we just have to write the element. The element is okay. So the first thing is you're just writing A, the name of the matrix, and the first thing is you are writing the number of the row which is in it. Okay, so you can see that it is in second row. Okay, so you write 2 here. Then you can count which column is it. In this case, you write here. Then now you can see that it is in column 3. Okay, so A 2 3. Okay, so if you are asked to locate 7, you can say that it is A 2 3. Okay, so this is how we locate values in a matrix. Okay, please locate this 8 and comment in the section which position is 8. Okay, so this is how we locate value. Okay, so if you are asked to look on a number which is let's say 3 2. Okay, so you're going to count the number of rows 3 and count the number of columns 2. Okay, so you're going to come at 10 here. Okay, so this is what we call locating the number of matrix. Okay, so the first thing is you just have to look at the rows, then you look at the columns. Okay, so let's say in this case you can just represent it as the matrix name, and this I represent rows and this J represent column. Okay, so this is the way you should locate values in a matrix. And now let's talk about types of matrix. Okay, so we can say that common forms of matrix. Okay, so there are many forms of matrix, but we are going just to talk about the common ones. Okay, so we're going to see other types as we go on. Now let's talk about the common matrix. Okay, so the first one, you know, it is a row matrix. Okay, so when a matrix, let's say it's a matrix A, in this case, it has just element in one row. Let's say it has elements 1, 2, 3. Okay, so they are in just one row. Okay, so it is said to be a row matrix. And again, on the column matrix is a matrix. Let's say we have matrix B, and the elements are here 1, 3, 5. Okay, okay, 5 like this. Okay, this is what we call the column matrix. They are just in one column. And a square matrix, it has the same number of rows and columns. Okay, so let's say for matrix C here, in this case, let's say we have a number 2, 4, 6, 8. Okay, so this is a square matrix because it has the same number of rows and same number of columns. Okay, so this is what we call a square matrix. Then we have a zero or a null matrix. Okay, so let's say a null matrix. In this case, a null matrix is a matrix where all elements are 0. Okay, so let's say we have an element like this, we have a matrix like this. Okay, so this is it. It has all zeros. We call it a null matrix. Okay, then we have what we call a diagonal matrix. Okay, so let's say let me give an example of a diagonal matrix. It is a matrix where that only the diagonal elements are non-zero. Okay, let's say we have a matrix like this, and we have 2, 0, 0, 0, 3, 0, 0, 0, 4. Okay, so this is our matrix. We call it a diagonal matrix because you can see that only these diagonal elements, okay, only these diagonal elements are not zeros. Okay, so this means that it's a diagonal element. Please make sure you understand that. Okay, so an identity matrix. Okay, so let's now talk about an identity matrix. It is represented by I. Please remember this. You can forget all these A, B, C, L like this, but this I, make sure you remember it. Okay, so an identity matrix is represented by I, and it is a square matrix. Okay, so this means that the number of rows and the number of columns should be the same. Okay, so in this case, we're going to go with 2 by 2. It is a square matrix and ones on the diagonal and zeros elsewhere. Okay, so it is a square matrix which is a diagonal matrix again, but these elements are ones. Okay, so in this case, we're going to see our identity matrix is like this. Okay, so you know that it is a square matrix 2 by 2. The number of rows are equal, and you can see that these diagonal elements are only ones. Okay, and others are zeros. This is what we call an identity matrix. Please make sure you remember this. It is a very important matrix. We're going to look at it in the future. In this last part of this introduction or to matrix, we're going to learn about why do we learn matrix. Okay, so let's understand what are the reasons we learn matrix. Okay, so the first thing is to represent data. Okay, so like we have students, we want to represent their data. We can represent their scores in a matrix manner, and we can represent weather states. Okay, the weather statistics, amount of rainfall, temperature, and so on. Okay, we can represent them in matrix form. And the other thing is the graphics. Okay, so when drawing and when animating the 3D animations, we use matrices to do those. Okay, those multiplication, those zooming and something like that. Okay, so this is a way we use matrices. Okay, then the other thing is we solve systems of equation. Okay, so if you have many equations with many variables, we can use matrices. Okay, then the other thing is in transformations. Okay, it is in geometry. When we transform this shape from that shape, we can use matrices to transform that shape easily. And the other thing is in robotics and engineering, we use matrices with the movement and something like that, in sensors and something like that. That data is stored in matrices and it is operated there. Okay, so that is the reason why we learn matrices. That was that on matrices. Make sure you tune in and subscribe so that you won't miss when we learn the important parts of this matrix topic. That was that. Thank you.